We'll be starting the broadcast in just a few minutes.
Hi, I'm Paul Morin with the Energy Conservatory, and welcome to our webinar titled Duct Leakage Testing. Some housekeeping items first. Please type in questions as you think of them, and we will be answering them as we go through the webinar. And we will at the end be covering a question and answer. We'll review the questions and answers, and you'll also have time to type in additional questions at the end. The webinar, as all our webinars are, will be recorded and are available on our website. So check out our website and see the past webinars we've done. And we're also in the process of updating those webinars now. And we always appreciate feedback on what type of webinars you'd like to see. A large part of what we do is webinars that are requested. So please give us some feedback on what you'd like to see in the future. BPI credits are available for this webinar. You'll receive one continuing education unit for today, and we will be updating that data to BPI, and you can check, probably in a month or so and make sure your credits have been awarded. We will not be providing any kind of certificate that you completed the webinar, but just check on our website, or not our website, but the BPI website, and make sure you've been awarded the credits. If you haven't given us your BPI number, you can still do that and still get credit for the webinar. Just email us at editor@energyconservatory.com and give us your full name and your BPI number. In order to receive the credits, you will need to be logged in under the email that you provided us to get the credit. So if you're watching this webinar with somebody else who's logged in, they will get the credits and you won't. So just so you make you aware of that. So what we're going to cover today is duct leakage basics, the type of tests that you can do, different types of HVAC tests that you can do on duct systems, setting up for a test, performing the test. We'll go over the test results and reports that you can do. We'll talk about calibration of equipment, and then at the end we'll also be talking about how to find duct leaks, because if you do the test and don't know where the leaks are, that's not very helpful. So why do we do the tests? Code compliance is the biggest driver now. Most states have adopted a code that requires duct testing. There are also new home programs above code programs that are taking place in almost every state, and they include Energy Star programs that require a home energy rating, a HERS rating, or utility. There's utility program incentives to do better than code on new construction. And also with these existing homes, there's also home energy ratings that take place on existing homes, and incentives from either government or utilities on getting good HERS ratings when doing renovations. And code compliance also does require, if you put on an addition and it has new ductwork, you can't be required to bring your old ductwork up to code, but you can be required to bring your new ductwork up to code. So you have to separate out the new from the old and run a test on that. So that's part of code compliance also. Diagnosing comfort issues on both new and existing homes is the duct blaster and other tests you can do on duct systems can help you identify comfort issues, and for sure lowering energy bills. I mean, that's the point of requiring it in code, and the incentives by utilities and states is to lower your energy usage and your energy bills. So the type of tests you can do on HVAC systems: total duct leakage, which measures all the duct leakage in the whole duct system. Duct leakage to outside, if there's duct work outside the envelope, doing a duct leakage to outside test will isolate just the leaks to the outside, and we'll talk a little bit more about that. That does require having both a blower door and a duct blaster to do that test. So you'll have both of them running at the same time to isolate the duct leaks to the outside. External static pressure. If you're doing duct sealing, it's important to know what this is and how to take those measurements. Sealing up ductwork will raise the static pressure in the duct system, and you don't want that to be beyond what the maximum for your system is. So doing that is important. Measuring air handler flow can help you diagnose comfort and airflow issues, and measuring airflow through registers. Are you getting enough BTUs to that room? If it's a room that is too cold or too hot, measuring the airflow to that room is a critical part of diagnosing the problems. Today, we're only going to be talking about the total duct leakage and duct leakage to outside. We won't be covering those other topics. System components. The duct blaster fan and the flow rings. So there's three flow rings for different ranges along with the duct blaster fan. There's a flex duct connection that connects to the fan, and the square transition allows you to connect to the duct system. And there's a flow conditioner in the third photo that will condition the air when you're doing a depressurization test, because the flow sensor and the flow rings are now inside the ductwork, and you want to straighten out that airflow before it goes across the flow sensor. So the flow conditioner, and flow conditioner I should talk a little bit more about that. When you put that flow conditioner in, it has there's a key. You can kind of see it on this photo where there's a little hump that sticks out, and then there's also a notch that's that same size on that you'll notice on the flow conditioner. And you'll want to push that flow conditioner all the way back as far as you can and line up that key and make sure it's pushed up against the back side of that round transition piece. When you're doing a depressurization test, the flow sensor, as I mentioned, is inside the flex duct, and you want to be measuring the pressure at the flow sensor with reference to the space the flow sensor is in. And now the flow sensor is in the ductwork. So you need to connect an extra tube that goes to that round transition piece on the flex duct. There's a plastic T there. You want to connect a tube there. And if you don't have, and that's measuring the pressure inside that duct in a few different locations. And if you don't have that flow conditioner pushed all the way back in there, you won't be reading the pressure inside there. So it's important to get that pushed back. And then also the pressure and flow gauge and the fan speed controller and the fan control cable come with the system, along with that carrying case. Everything will fit inside that carrying case. And it comes with a sample roll of the register sealing film to temporarily seal off all of the registers. And that sample roll is about 100 feet long, and it's perforated every 4 inches, so that'll get you through your first few houses. And it also comes with a static pressure probe, and that's used to measure the pressure inside the ductwork. Some optional items that you can get is a duct blaster fan can move up to 1350 CFM at 50 Pascal. So you can use it for a blower door test. We do sell a red nylon panel with the hole in it the size of the duct blaster fan. So if you're doing code compliance at 3 air changes per hour, you can test a small to medium sized homes up to about 3,000 square feet and get it up to 50 Pascal. So that's makes it a lot easier to do a blower door test if you can carry around the duct blaster fan, and in a lot of houses that would take care of it. So if you're testing a new home and the code requires total duct leakage test, you only need to bring 1 fan into the house. If you can't get it, if you can only get it to 10 Pascals, you'll need to go back out and get your blower door fan. But it is nice to be able to use a lighter weight fan, especially if you're testing a number of townhouses or apartment units. Having that smaller fan it has its advantages. We also sell the duct mask register sealing film in a case, by the case. And a case includes 6 rolls, and those rolls are 200 feet. We also have a field calibration plate that goes on the end of the square transition piece of the flex duct, and you tape that on the end, and you could do a test to see if your system is within the calibration range. So it doesn't tell you if your gauge is calibrated properly or your fan is calibrated properly, but the whole system is within the calibration range. So the duct blaster fan, the pressure and flow gauge, and the flex duct as a system are within the calibration range. So a total duct leakage test, total duct leakage pressurization test is what we're showing here. So we've got the duct blaster fan is blowing air into the duct system. If we bring it up to 25 Pascals, and that's the pressure in the duct with respect to the house. If that attic is well vented, then the duct to attic pressure will be very similar to that, especially if the airflow is less than, say, 300 CFM at 25, then the pressure distribution through all the ductwork is going to be very similar. So all of the leaks will be seeing the same pressure. And that's important when you're doing a duct leakage test. You want all of the leaks to see that full 25 pascals of pressure. So if we have a well-vented attic, then that'll be seeing 25 pascals also. So the less than 300 CFM at 25 of flow, the pressure throughout the whole supply side will be very similar. And the same as if you have the ductwork in a crawl space and the crawl space is well vented to the outside, then you'll have uniform pressure between the duct system in the house and the duct system and the crawl space, and all of those ducts will be seeing that 25 pascals of pressure, and you'll get a good test and a good repeatable test. You want the house to be set up properly and the ductwork to be set up properly, so you've got an accurate and repeatable test. You'll also want to have a window or a door open to the outside during the test, because when you're doing the duct leakage test, if you do have duct leakage to outside, that duct leakage to outside is going to act like an exhaust fan, and it's going to change the pressure in the house. And that's your reference pressure. The house pressure is your reference pressure. So you want to make sure that if you have duct leakage to outside, that pressure in the house is relieved. So your reference pressure is actually stable. So setting up for a test, first step is to prepare the house, turn off the air handler, remove the furnace filters, prepare the ductwork for the test, choose a location to attach the ductwork, choose a location to measure the pressure. So to prepare the house for the test, when we're doing a total duct leakage test, so that's measuring the duct leakage of the whole system, we want to leave a window or door open like we talked about. We'll also want to open access doors to unconditioned spaces. We want to open those to the outside. So I talked about a well-vented attic or a well-vented crawl space. If there's any doors between the crawl space and the outside, you want to open those up. And same with any unconditioned spaces, you want to open those to the outside as much as you can. So the whole ductwork is seeing that 25 pascals of pressure. And for the test to be repeatable, you'll need to know what that condition is and how you set it up. Duct leakage outside, when you're doing that test, now you've got the blower door set up too. So you'll need to set up the house in blower door test conditions. So you won't have a window or a door open to the outside. You want that space you're testing, the conditioned space, to be all one zone. So you'll want to open interior doors. If you've got a conditioned crawl space, you want to open between the house and the crawl space if you can. So all the conditions, just like when you're doing a blower door test, you want to set it up in those conditions. So that'll be the setup for the house conditions. You want to temporarily seal all the registers during either a total duct leakage test or duct leakage outside test. It's very important to seal over all the registers during both of those tests. Next, you want to choose a location where you're going to attach the fan to the ductwork. And if you have 3 or more returns, you want to connect at the air handler. And if you're doing a pressurization test, you have the option of using the flex duct or not. You can get more airflow, and maybe it's easier, maybe not, to connect up to the air handler without the flex duct, but you have that option. So if you need more airflow, the flex duct does restrict the flow, which certainly doesn't change the pressure, but it does restrict the flow, the total flow somewhat, because it's adding more resistance. But you do have that option of connecting directly to the air handler or using the flex duct to connect to it. If you have 3 or fewer returns, you can connect at the largest return. And again, if you're pressurizing, you can connect the fan directly to there. Next step is deciding where you're going to measure the duct pressure. So you'll insert a static pressure probe into the ductwork, so it's pointing into the direction of the airflow. So the airflow is coming across the point of the static pressure probe, and you've got a few options on where to locate that. A good place is just right in the right in the supply trunk line. Another option is installing it at the closest supply register to where the duct blaster fan is installed. If you're measuring at that location, there's really no airflow at that location, so you wouldn't necessarily need the static pressure probe. You could just stick your tube in there, and because you're really measuring static because there's no airflow at that location. So that's another option. But if there's registers on there, you know, the static pressure probe has a magnet, and it's easy to seal across it with the duct mask, register sealing film, and then poke the static pressure probe through there. Another option, if you're connecting to the duct system with the fan at a center return, then you could connect the static pressure probe right in the supply plenum. But we recommend only putting that at the supply plenum if you're connecting at a return. Then you'll run a tube from the static pressure probe to the input on channel A, and you'll run a tube from the input on channel B to the brass tap next to the handle on the duct blaster fan. If the pressure and flow gauge, either a DG700 or a DG1000, is outside when you're doing the test, then you'll want to be referencing the house on channel A. So in this case, we've got a package unit that's sitting out in the side yard, and the gauge is outside. On channel A, we want to be measuring the pressure in the duct with reference to the house. So we'll need to run a reference tube inside. So this will be the case if you're set up and the gauge is in the attic, or if the gauge is in the crawl space, or the gauge is in a garage. If it's outside of the house, you want to be measuring the pressure of the duct with reference to the house. So you'll need to run a separate tube. For leaky duct systems, sometimes if you're measuring ductwork in existing homes and they're using any stud cavities or joist cavities for returns, or if there's disconnected ducts, you'll see really high leakage numbers. And when you start getting over 500 CFM at 25, you're going to get uneven pressures across the duct system. So what we recommend is to do two tests. One measuring the pressure at the closest supply, one measuring at the pressure at the farthest supply, and then average those two results, because like I mentioned previously, the total airflow is based on where the leak is, how big the leak is, and what the pressure is across the leak. And if you've got different pressures across all of the leaks, you get some kind of funky numbers. So by measuring at the farthest and measuring at the closest and averaging the results is the best option. So in performing a test, the way you will set up the gauge for the test, when you first start up the gauge, you'll come to the home screen, and from the home screen, choose the tubing assistant. And we're doing a duct leakage test, so you'll choose that. We're going to pressurize, so we'll choose that. We're inside the house, we'll choose that one. We'll choose the duct blaster fan. And now it's asking us to confirm our selections. We've chosen duct tightness, pressurized, ducts inside the building, and we're using the duct blaster B fan. So hit continue. And now what it's showing us is we want to connect the tube from the input on A going to the duct, and input on B going to the duct blaster fan. So it shows us how to connect that tubing. And then we'll hit the start button. Okay, now we see those colors stayed with us. So it's showing the duct going from channel A to the duct, going from input on channel B to the fan. It also set up our mode. So on the DG700, you had to switch the mode. This set up the mode for us. It also set up the device for us. It set up the device to the duct plaster bead, and it set our cruise to 25. So it set up all of those things for us. So that makes your that makes your job really easy, just to quickly step through those 4 things, and then it sets up everything else for you. Next, we'll want to set up what ring we have on. So we'll click, you can see open fan is where our ring selection is here. We'll click on that, and now we can choose ring 3. So it set up a ring for us. And you'll notice, so this is the configuration pull-down menu here. We also have a device pull-down menu and a mode pull-down menu. So we could choose, changing either of those if we want also from this one page. Now I'm going to go back to the back arrow here, and that brings us back to the gauge, and now we're set to ring 3, and we're ready to do the test. So now we'll either turn up the knob or we'll click the cruise button, and that'll bring us up. We want to get within a couple of pascals of 25. We're in the pressure flow at 25 mode, so it's going to correct whatever that pressure was for 25 and display our results here. We also, you can click on the hold button, and when you push hold, what that'll do is it'll lock the screen and turn the fan off. So that's also convenient to have that option. And then the results, if you need a report, and if you're doing code compliance, the way the code is written is you're supposed to provide a report with your signature on it to the code official. So we've got an auto test app that allows you to do an automated duct leakage test that provides a really nice report. And it provides the report in a PDF format, and you can download free apps that will allow you to, it's a PDF reader that will allow you to sign it. So that's a nice feature too. So you can create that PDF and open it, sign it, and then email it off to either email it to a code official, or you could, if you've got Dropbox or Google Drive on your phone or your tablet, you can send it up there. And this app works on either iOS devices, iPhone, iPad, or Android phones or tablets. So once you open that software, you'll go into it and you'll set up all your settings, and you only need to do that one time. So you'll set up the type of tests you typically do. If you're doing a code compliance test and it's 4 CFM per 100 square feet of floor area, you'll set that up. So when it generates that report, it'll show right in the middle of the report in bold letters, it'll say what the results were in CFM per 100 square feet, because that's what the building official is interested in. He doesn't want to have to read through a bunch of data to find out what the results are. They're bold, right front and center, and it tells you what the results were, what the target is, and if it passed or failed. So you'll have all the information you need. It'll be easy for the building official to find it. And in the one-time settings, you'll put in all of your information and any certifications you have and your company info. And once you enter that in once, it's in there. And then when you go to the home, you can use the geolocator in the software to create a geotag. So the report will include a geotag of where you were and what time you did the test. So that's a good quality control feature to have. And once you do the geotag, it'll also tell you what the address is at that house, and it'll populate the address fields for it. It'll also, for a blower dart test, it'll determine what the altitude is at that location and pull that information in the report also. So a real time saver. So now you're ready to run the test and generate a report. And this is what the report looks like. So you can see, you know, front and center in bold is you're at 3.66 CFM, and the target is 4. So compliance with tests you passed. So that, you know, that information is right there. It's also got your company information, your name and the building information and customer information. The customer might be the builder, but the building information is the address where you're doing the test. So, so good to have, you know, you got to have all that information plus more information about the test results and then a graph of your test. So if you're doing a depressurization test, what's different? You do need to include the flex duct if you're doing a depressurization test. Some people prefer depressurization. I think most people still do pressurization tests because I think it's easier. But if you're doing some people like depressurization because that's sucking the register sealing film into the register instead of worrying about having to blow it off, having to worry about blowing it off. But you must use flex duct when you're doing a depressurization test. You have to use that flow conditioner like we talked about earlier when you're doing a depressurization test. You need to turn the fan around. So the side with the rings on, the inlet side of the fan is the side with the rings on, and that's inside the flex duct. So you're seeing the grill, the outlet side of the fan now. And you must use a ring when you're doing a depressurization test. You can't use open fan, so that kind of restricts what your total flow is. You can't get up to 300 CFM 50 if you've got ring 1 on and the flex duct. But hopefully you don't need that much airflow when you're doing a duct leakage test. So you must use a ring, and you need to connect an additional tube. So we talked about the round transition piece where the flex duct connects to the fan, being able to measure the pressure inside that flex duct. There's a plastic T connector that you need to connect that third tube to. And you need 4 feet of straight flex before the fan. So all of these things are being done to straighten out the airflow before it goes across the flow sensor. So having 4 feet, the flex duct is 12 feet long, but the 4 feet before the fan, directly before the fan, needs to be straight to help straighten out that airflow and pull tight, you know, as much as possible. So you've got 4 feet of straight flex duct before the air hits the fan. You've got the flow conditioner to condition the air a little bit more. And you've got a flow ring, which also helps condition the air. Helps the air is concentrated more over where the flow ring is. So to get accurate readings with a depressurization test, you need to do all of these things. Now we'll talk about duct leakage to outside pressurization test. So now we've got a blower door set up to pressurize, and we have the duct blaster set up to pressurize. So the blower door is blowing air into the house. Whoops. Blower door is blowing air into the house, and the duct blaster is blowing air into the ductwork. So they're both set up to pressurize. Now the blower door fan, the inlet side of the fan, if you've got a newer fan, needs to be outside. So the ring side of the fan needs to be outside, and you're blowing air into the house that way. With our older fans, they had a reverse switch, and this is really the only instance you would use that switch. You can't use that switch to measure airflow. You can only use it to pressurize the house. So if you're doing the pressurizing the house for diagnostics, or you're pressurizing it to do a duct leakage outside test, then you can use that reverse switch. So when we're doing a duct leakage, like I talked about, the blower door is blowing air in, duct blaster is blowing air in. We've got our gauge in the house, and we've got a tube from the reference on channel A that's going to the outside. And in this case, we just have it in the pressure mode. You don't have to be. You can be in whatever mode you want, because you're not measuring flow at this point. You're only measuring pressure. And channel A is always reading pressure. So you can have channel B at pressure, pressure flow at 50, whatever you want. That's irrelevant, because we're only looking at the reading on channel A. So we're setting it to cruise. We're setting it to cruise 25 pascals. Remember, when we turn the duct blaster fan on, that is blowing air to the outside, and if we've got ducts on the outside, it's going to change. It's going to act like an exhaust fan if we're blowing air from the house to the outside, and it's going to change the pressure in the house. So that's why it's important to set the blow at our fan to cruise 25. So then, as we're blowing more and more air into the duct system, and it's changing the pressure in the house, the cruise feature can adapt for that. So then with the duct blaster gauge, we will go from the input on channel A to our ductwork, and input on channel B to the duct blaster fan, and we're pressurizing, so we don't need that third tube. Our duct blaster fan will be set to pressure flow, not pressure flow at 25. We need to be set to pressure flow when we're doing this test, because when we're set in the pressure flow mode, it's displaying what the flow is through the fan. When we're at the pressure flow at 25, it's showing what the flow would be if we achieved 25. Well, if we're at 0, it can't determine what the flow would be at 25. That you'll notice when if you're doing a total leakage test, it'll show 4 dashed lines on channel B until you get above 5 pascals. So it's trying to convert the flow to what the flow would be at 25, and it can't do that unless the pressure is high enough. It certainly can't do it if the pressure is at 0. So that's why it's important to remember we need to be in the pressure flow mode, and our goal is to get the pressure in the ductwork to the same pressure as the house. So now our house is at plus 25, or close to plus 25, and our ductwork is at the same pressure as the house, or 0 pressure difference between the house and the ductwork. And when we do that, when we have the house and the ductwork at the same pressure, there won't be any air leakage across any leaks in the house, because you need both a hole and a driving force to get any leakage. So now we're eliminating all the leaks that are inside the house, and all of the air blowing through the fan is going to go to the duct leaks that are outside. So that's how a duct leakage outside test differs from a total duct leakage test. And the reason that it makes sense to do that test is the duct leaks with the biggest energy penalty are going to be supply leaks to the outside, and then after that would be return leaks to the outside. And they'll make the biggest difference in comfort also if you've got duct leaks on the return side or supply side going to the outside. Test results for code compliance: the 2009 International Energy Conservation Code, IECC, 2009 International Energy Conservation Code. If you're doing the test post-construction, after sheetrock and everything is done, the standard is you need to be less than 8 CFM or less. 8 CFM per 100 square feet of floor area. So if you had 1,000 square feet of floor area, that would be 80 CFM of duct leakage. If you're doing so that's leakage to the outside. If you're doing a total duct leakage test, so with just the duct blaster, not blower door and duct blaster, total duct leakage test, you're allowed up to 12 CFM per 100 square feet of floor area. If you're testing at the rough-in stage before sheetrock, and that's beneficial for a heating contractor because then they know if they pass or fail before all the ductwork is hidden. Total duct leakage then is 6 CFM per 100 square feet of floor area. Total without the air handler is 4 CFM per 100 square feet of floor area. So those of you who are in areas that adopted the 2009 code and then adopted the 2012 code, that was kind of a in-between point where you got used to doing duct sealing. It didn't have to be perfect, but you kind of got used to the fact that you're going to have to seal ductwork. In Minnesota, we went right from the 2006 to the 2012. So they needed 4 CFM of total duct leakage. Now duct leakage, the outside isn't part of the equation. You have to do a total duct leakage test. You only have to do the test if you have ductwork outside the envelope, outside the heated boundary of the house. But you do need to do a total duct leakage test. So it's counting the duct leaks inside and outside, and it needed to be 4 CFM per 100 square feet of floor area. We ended up doing a lot of training with contractors to show them how to do the duct leakage test, how to find the leaks, and also how to seal. We did hands-on on how to seal the ducts and then test them after you sealed them. And it's hard to get down to 4 CFM per 100 square feet of floor area if you're not used to building tight duct systems. And oftentimes you have to change the way you're installing ducts also. Can't use floor cavities or joist cavities anymore for duct work. And it's certainly better if you assemble, for example, if the ductwork is going on the ceiling in a basement or on the ceiling in a crawl space, you may have to put all of those takeoffs and elbows on that trunk line first and seal them before you attach it to the ceiling. So then you'll put it up in one piece rather than doing it as you go along. So some of the, physically how you put the systems together and put them in changes also. So you're not blindly trying to seal the ductwork. You're sealing it when everything is visible and readily available, and then you can get all of it sealed really well. At rough-in, total duct leakage 4 CFM per 100 square feet of floor area, so it's the same whether you test it at rough-in or you test it with a sheetrock on. The target is the same. If you test it without an air handler, the requirement is 3 CFM per 100 square feet of floor area. The 2012 and 15 code also require an airtight air handler. So that air handler needs to have a stamp on it that says it meets a certain air tightness requirement. You can't put in just any air handler or furnace. It needs to be one that has an air tightness meets an air tightness standard. Calibration of equipment, DG700 and DG1000, every 2 years we recommend a calibration, and we do that factory calibration at our factory. So you ship the gauges to us, and we do a calibration, and you get a report that shows what the calibration was when it came in and what the readings were when it went out. So inside the gauge, there's a chip that shows when that calibration was done. So whenever you generate a report, it can show what that calibration date was. So you can confirm that the calibration, the equipment you're using has been calibrated. You can also do a field calibration check. And the way that's done is you'll send in one DG7 or one DG1000 to us. We'll do a calibration on that. And when that goes back to you, then you can compare, your company could compare all of your other gauges against that gauge. And on our website, it shows the the procedure on how to do that field calibration check. So that's an option for you also. And most HERS providers will allow for that field calibration check. So you can, if you have a record of that, you can do that. I do recommend that you use our tech log software when you're doing that field calibration check, because what that does is it recognizes your gauge serial number and the date of calibration. So you'll have, and it's a graphing software. So you'll see on the graph that the two gauges that are being compared, that one of them has been calibrated recently, and that's the one you're comparing to. So that's that it's helpful to use that extra level of quality control. So you've got a documented test that shows the calibration for all those gauges. The duct blaster fan will stay within calibration unless it's been damaged. So you want to check that in the manual. In the Appendix A, it shows what you need to do to check all of those things that affect calibration. So you want to check the flow sensor for leaks to make sure there aren't any leaks. So there's a metal tube that's not likely to leak, but the connection to the hose, and that hose goes up to the brass tap. You want to make sure that check the integrity of that. The position of the motor and the position of the flow sensor matters. There's a couple of bolts that are holding that flow sensor in place, and you can tweak the reading of the fan a little bit by pulling that, moving that flow sensor in or out a little bit. So if that's been moved, that can be adjusted. And or if there's any damage to the fan housing, where there's holes in the black fan housing, that also is gonna affect your readings also. And so the duct calibration plate, we talked about that before. You need to set up the fan to depressurize when you're doing this test. So you'll need that flow conditioner, you'll need ring 3, and the flow rings will be inside the flex duct, which means you'll need that extra tube connected. So we're seeing the outlet side of the fan here, because they're depressurizing that duct. And the reason you have to depressurize is you've got this calibration plate, and if the air is coming out of this hole, you're going to have a lot of turbulence at the end, and we're not going to get a stable reading. So the air needs to be going the other way. It needs to be going through that hole, through the flex duct, and out through the fan. So the outlet side of the fan is the side that we're seeing here, to get a stable reading there. So we'll connect a tube to that point. We're measuring the pressure there. We're bringing it up to 25 pascals, and we need to be within 106 plus or minus 3 pascals, I think is what it is. So, or maybe it's 109 plus or minus 3, but the instructions come on the calibration plate. So you'll set it up to pressure flow at 25, you'll bring it up to 25, and you get your reading. We do have a ring 4 now for the duct blaster fan. It's an optional ring, and that allows you to read down to 2.5 CFM. So the ring 3 goes down to 10. This allows you to get down to 2.6 CFM. And you will need to, instead of connecting the red tube to the tap by the handle, you'll connect to a tap that's provided on ring 4. So you're just reading the pressure across that hole, that small hole in the fan. So if you've got a DG700, you don't have a ring 4 option, and you'll need to use this flow chart. You'll connect up the, to the tap on channel B. You'll connect to that tap on the ring 4, and then you'll connect that to the input on channel B channel A will go to the ductwork like you normally would, and you need to get channel A up to 25, just like you would with any duct leakage test. You'll need to put the gauge in pressure mode, and channel B is reading the pressure across that hole in the duct blaster ring 4, and this chart converts that pressure across that hole to flow. So it's a little bit different than using ring 3. If you're using a DG1000 that has the option of ring 4, and you do it like any other test, but this is a little different if you're using the DG700. You're connecting the red tube directly to that tap. It's reading the pressure across that hole, and then you convert the pressure across that hole to flow based on that chart. Finding duct leaks. So the duct test tells you how much leakage, but it doesn't tell you where the leaks are. So you're going to have to find the leaks. One of the common places the leaks will occur is that takeoff where the branch lines connect to the trunk. That's one of the most common places where it leaks. It'll also leak wherever pieces of duct are connected to each other, or the longitudinal joints. All of those will need to be sealed because they all leak a little bit. But the biggest leaks are usually at that takeoff connection. If you have a disconnected duct, that's certainly going to be a big leak also. Hopefully you don't have any of that. If the ductwork is connected to framing in any way, either wall cavities or joist cavities, you're going to get leaks in those locations, and probably enough so you won't pass that 4 CFM per 100 square foot duct test. You have to avoid, it's not allowed in the code anymore, and you're not going to pass the test if you do have any building cavities where air could be pulled in through those. So those need to be eliminated. You do need an airtight air handler also. It's required by code, and if you're going to pass the test, your air handler needs to be pretty airtight. You can also find where those duct leaks are by using a blower door and a pressure pan. So you'll bring use the blower door to maintain 50 pascals. You'll cover the registers with the gasketed pressure pan one at a time, and you'll measure the pressure at that location. So typically, ideally, you'd have 2 gauges to do this. One to set the blower door to cruise 50, and another one to walk around, connect the tube to the input on channel A, and read the pressure. And the highest pressure to record all the pressure at each register, and the highest numbers are closest to the biggest leaks. So that's how you use that to track down where the biggest leaks are. You can also, heating contractors will often use foggers also to find where the leaks are. You want to use a fogger that uses a non-corrosive fog, and most of them will, that you would buy at a party supply store or a theatrical smoke place. What I've heard is that theatrical smoke generators, the more expensive ones, will produce too much fog for testing ductwork, and it will fill up the basement or the attic full of smoke before you get a chance to find the leak. So usually the inexpensive ones that you can get at a party supply store are adequate and can aid in helping you find the leaks. It's best for sure to use open fan, and so you're turning on the duct blaster fan too and pressurizing the ductwork slightly. You want to use open fan so you're not concentrating that fog right over the flow sensor. You don't want to be blowing directly onto the flow sensor or the motor. You want it to be kind of pointing towards off to the side of the duct blaster fan a little bit, so it's not coating the fan with with smoke. We have seen fans come in for repair where people have been using like a smoke bomb or something like that, and those are very corrosive, and they'll tear apart the electronics. They'll eat up the electronics pretty good, and now you're not going to have an accurate fan, or you're not going to have a fan that even works anymore. So you want to use a fan that has something like a glycol solution that's non-corrosive. So this is showing around an air handler that it's foggy. It's foggy around the air handler, and all the leaks are coming out at that location. So helps you find where the leaks are. It's going to be a little harder if you're using like a rigid duct that's covered with an insulated flex. It's going to be harder to find those leaks. But if you've got just straight insulated flex or metal ducting, it should be easier to find it. And if you're using a metal trunk line in an attic, you'll want to test it for duct leaks before you put any insulation around it, for sure. So you can help find the leak. So this is showing duct mastic on all the joints and longitudinal seams. So it's showing this being put on with a paintbrush. It's water-based, so a lot of guys will just either put gloves on or just grab it with their hands and smear it on. You can certainly use a paintbrush too, but you're not painting it on. You're not putting it on thin like you put on paint. You're putting it on very thick. What the manufacturer recommends is that it be nickel thick. So you're gobbing it on there pretty thick in order to not crack in the future and in order to make a good seal. There you can see some more mastic. And this one, you can see they did the longitudinal joints, but they didn't do the one in the back. You'll need to put some, for bigger cracks and bigger leaks, you want to use some mesh tape and put that on first, and then goop over it with the mastic. So they missed that one, and that one was still leaking. So and that would show up in a smoke test. So that concludes our webinar. So we'll be reviewing the questions that we had. Thanks for attending the webinar. And as always, please send us comments on what you would like to see in the future and future webinars. And I've got my contact information here. You can either email me or my direct number is there. You can give me a call if you have any additional questions. And now we can review the questions that we've had so far.
So it looks like we haven't had anybody type in questions as we're going along. Up at the top, there's a Q&A part, and if you have specific questions, go ahead and type them in there. Looks like, let's see, chat. Oh, it looks like we do have some under chat here. Okay, let me review those. Okay, let's start at the top. How do you use the duct blaster field calibration plate? We did cover that. When using the blower door to look for duct leaks, do the duct registers need to be sealed? When you're using the pressure pan, the answer is no. When you're using the pressure pan, the blower door and the pressure pan to find duct leaks, you would not have any of the registers sealed. You want to be testing them just one at a time. And we will have, this recording will be on our webinar. I mean, this recorded webinar will be on our website, so you'll be able to see that. If you're a trainer and you want copies of the PowerPoints, I can certainly provide provide you with that also. So it looks like you could type in questions either under chat or in the live spot. So another question's coming in. Open attic hatch during depressurization, total leakage, yes. You would want to either open that hatch to the outside or open it to the house. Open a hatch to the outside or open the hatch to the house. So the house, the main goal is to have the ductwork open to the outside. You want to have that ductwork open to the outside. So it's not, if the attic isn't well vented, then yes, you would want to open the attic hatch to relieve that pressure in the attic caused by running the test. So that's a good point, that if you've got ductwork in the attic, you would want to open the attic hatch during a total duct leakage test. Can DG 700 and 1000 be used for the same test together? And yes, you can mix and match gauges. They both have about the same level of accuracy. DG 1000 is a little bit more accurate, but they are right. They're both well under 1% accuracy. The DG 700 is about 0.5%. When it comes from the field, and the 1000 is a little better than that, but they're both very accurate, so they can certainly be used together on a test. Question is about the software to calibrate the DG 1000. That is not available. We're the only ones who can change the calibration that's on the board. We're the other ones who can change that calibration. You can do a calibration check, and there's information on that on our website, or you could send me an email and I can send you that documentation. And we do have a little, you do need some extra T's and tubing, but that document shows you how to set that up to do the test. You do need a 1 milliliter syringe and 30 feet of tubing. And that protects so you don't overpressurize the gauge. That's important, that you have 30 feet of tubing and just a small 1 milliliter. We do sell a kit that includes the T's and short pieces of tubing in that syringe. You can get one of those from us if you have trouble finding any of those things. And it has instructions on how to do that field calibration. So that's not changing the calibration of the gauge like a factory calibration would. It's just checking it against the gauge that was recently calibrated. You can use our TechLog software. That's a free download from our website that would allow you to graph that calibration test. I did talk about that. That software is called TechLog 4, and that's a free download from our website, or send me an email and I can send you a direct link to that software. And we've done past webinars. If you go to our website, under the 2015 webinars, there's a webinar, the first webinar there, it talks about using that software to do to monitor pressures. So you could just watch that webinar and learn how to use that TechLog software to do a it would show you enough so you could do that calibration. Or it's usually really easy to just give me a call and I can talk you through your first time running it also. Does the app provide a report which includes more than one system on the same report? And the answer to that is no. Our current reports in our current software, you can only control one fan from it. So it would not include a report for multiple fans. So if you're doing a duct leakage outside test, we don't have a test. Our TEC auto test app does not currently include that duct leakage outside test where you're controlling more than one fan from a test. I think at some point it will, but our software engineers still have a pretty long list of things to do before we would add that to it. So we probably will at some point, but not quite yet. What happens if you have the fan open during a depressurization test? You won't get accurate information. That's, it's as simple as that. You'll be out of the calibration range of the equipment, and it'll give you a number. but we've done enough testing on it to know it's not going to be accurate, but not enough testing to know how inaccurate it is. Just that it's not within the calibration range of the equipment, so it's not recommended. You can always turn the fan around and do a pressurization test if you can't get up to pressure during depressurization. We have not done a webinar on how to seal ductwork. We used to have, back in the VCR tape days, we used to have something on sealing ducts. So I'm going to have to look back on that, see what we have. We may be able to put something on our website if we could go back to some of those old videos we had and update those. So that's a good point. I'll take a note of that and see if we can't get something on our website that talks about duct sealing. Preferred location for the pressure hose monitoring, the duct system. I'm assuming that's during a duct leakage test. Where's the best spot? What I would always do is just put it in the closest register to where the duct blaster fan is connected up. That's a simple one. You don't need to use the static pressure probe if you don't want to, and I think that's the best location. And again, the pressure in the duct system at low flow. So if you're less than 150 CFM of duct leakage, your pressure throughout the whole duct system, no matter where you measure, is going to be pretty similar as long as you're on the supply side. You don't want to be measuring on the return side, and none of the standards allow for that. I know the 300 or the 360 resonant 360 did allow you to tee the supply and return together, but I think they're going to retract that. We've had some discussions with them about that, and I think they may backtrack on that, at least from the last discussions we had. It sounds like they're going to. We, as the manufacturer, we recommend only measuring on the supply side, and at a closest supply register is a good location. Follow up on that hatch question. Our attics are typically vented both soffit and ridge, still open the hatch. What you can do is if you measure the pressure between that attic space and the outside, and it's pretty close to zero, then the pressures you wouldn't need to open the attic hatch. Your pressures aren't changing in that duct system, and you wouldn't need to open the attic hatch. So the main thing we're concerned with is that the duct leaks are going to change the pressure in that attic, so they're maybe not seeing the full 25 pascals that we want to see. If they have, you can usually tell if there's an adequate amount of soffit and ridge vents or the turtle kind of vents, and you may not need to open the attic hatch. Can you do a pressurization of a system when return and sealing is used for the flex duct with the duct blaster, yes, if you're connected with the flex duct to and the duct blaster to the sealing return, you can do either pressurization or depressurization tests. Certainly, that would be fine. Is there a quick battery check on the DG1000? Yes, there's an icon up on the upper right screen. There's an icon that shows a battery, and it will show the charge. And if you hover over that little icon, it'll tell you what percent charge is left on it. So yes, there is a way to have there is a battery check on the DG1000. Future webinar, TESP, so total external static pressure. That's a good idea. I think we probably may have covered under one of the getting the most out of your manometer webinars. But yeah, that is measuring static pressures is a good topic, and that would be a good topic for a webinar for sure. This is a good suggestion. Let folks know it's important not to get duct mask on paint, especially where I would see the most issues is if registers are painted and you put the duct mask over that, it can peel the paint off. And I think the reason for that is that you've got a new register, it's got kind of an oily film on it, and if you don't do prep work on that, clean it off and maybe sand it a little bit to rough it up, the paint doesn't stick very well to it, and it'll peel off pretty easily. If you see painted registers, and the same with if it's plastic, some of the sealing registers are plastic where you unscrew them to get more air out of them. And if those are painted, those are notorious for pulling paint off too. But yeah, and I haven't experienced it pulling paint off of walls, but I'm sure that's possible too. And it does, depending on, I think some of the film is better than others. I'm pretty comfortable with ours being put over paint, but I know other ones are a little more aggressive and maybe more likely to pull up paint. So it's good. We're getting lots of questions, feedback here. Wallpaper, especially old wallpaper, seems to be an issue with the mask too. Some other things that are options are using like either cardboard or paper or you know, some kind of film like that, and then painter's tape. That's kind of your alternative solution if you're finding that paint is being pulled off, and you don't want to be in that position where you're pulling paint off of registers or pulling paint off of walls or pulling wallpaper off of a house. So be careful and have some backups in case that becomes an issue. Will the DG1000 offer reading in units other than pascals? It will read in inches of water column. It does have that units change. You have to go into the settings and change that. But that changes both sides of the gauge. So you can't read inches of water column and CFM, for example. When you switch it to inches of water column, you'll see inches of water column on both sides, and you'll just be in the pressure mode. But mechanical contractors for sure are used to using inches of water column and would rather see that, especially for measuring external static pressures and and doing diagnostic work, they're more comfortable with that. And certainly that's an option with the gauges. And another thing with, if you've got a DG 1000, excuse me, we have updated those. We do keep updating those. I think we're on our 4th one now, and the last update included Bluetooth. The gauges always had Bluetooth, and this just enabled it. And we have software that we have apps for iPads. Not quite, we're not there with Androids yet with Bluetooth, but there's so many different types of Bluetooth, and it's displayed, you know, what it looks like. The app looks like on the screen is different depending on who the manufacturer of the Android device is. So we're not quite there yet, but make sure and make a, you know, you connect your DG 1000 to an internet connection through a router, and then check and see if there's an update, and that's all you need to do to update your gauge. And if you're not seeing inches of water on your gauge, then maybe you need to do an update. If you're not seeing Bluetooth on it yet, you need to do an update. And if you have any other questions, again, feel free to give me a call or send me an email, and we'll get you covered. Okay, it looks like we have covered all the questions that are coming in, and all the chat, the webinar chat line parts of it. So thanks for attending our webinar. Thanks for the feedback. Feel free to email me with more feedback as you get a chance. And thanks for attending the webinar.